Hello, friends. A U.S. Navy aircraft carrier is a floating city with 5,100 sailors who need to eat every day. These ships, part of the Navy's fleet of 11 carriers, are always on the move, often far from land. Feeding this many people requires preparing 17,300 meals daily. Covering breakfast, lunch, dinner, and a midnight meal called mid-rats for night shift workers. Each sailor needs proper nutrition to stay healthy and ready for duty. Men require 2,850 calories a day, while women need 2,100. This means chefs must plan meals carefully to meet these needs. The process starts with menu planning. Chefs create menus that last 14 or 21 days, ensuring variety and balance. They account for food allergies and religious diets, so every sailor has suitable options. A typical menu might include beef, barbecue chicken, mashed potatoes, steamed vegetables, and fresh bread. For special occasions like Thanksgiving, chefs prepare turkeys and pastries to remind sailors of home. Planning also involves calculating calories, fat, and sodium to keep meals healthy. This detailed work happens weeks in advance, setting the stage for the massive effort to feed thousands at sea. The scale of food required is staggering. A single deployment needs 1,600 pounds of meat, 350 pounds of lettuce, 160 gallons of milk, and 20,000 cups of coffee. Chefs and planners must ensure these supplies are ready before the ship leaves port. This careful preparation keeps the galley, or kitchen, running smoothly, even in the middle of the ocean. Getting food to an aircraft carrier at sea is a complex task. Every 7 to 10 days, logistic ships or aircraft deliver between 400,000 and 700,000 pounds of food. These resupply operations require the carrier to maintain a steady speed and position while goods are transferred, often in rough seas. Sailors work together to unload crates quickly and store them properly. The ship has separate areas for cold, frozen, and dry food. Fresh items like vegetables and fruit are used first because storage space for them is limited. Canned and frozen foods make up most of the stock and are used later in the deployment. Once food is on board, the galley operates 24 hours a day. Chefs work in shifts using industrial equipment, including pots that hold 80 gallons and large ovens. They cook in batches to ensure meals are hot and fresh for each serving. For example, bread is made from scratch. Chefs mix large cans of flour in industrial mixers, knead the dough, and bake it in ovens to produce crispy loaves. The midnight meal, mid-rats, combines leftovers with new dishes to feed sailors working late shifts. The galley is a high-pressure environment. Chefs coordinate to keep food flowing during set meal times. Breakfast from 6 o'clock to 8 o'clock, i.e. M. Lunch from 11 o'clock, i.e. M to 1 o'clock p.m., and dinner from 4:30 to 6:30 p.m. Every day they serve thousands of meals without pause, ensuring no sailor goes hungry. This non-stop effort keeps the crew fueled for their demanding job. Sailors eat in large dining halls, similar to school cafeterias. They line up to get their food and sit together at long tables. These meals are more than just food. They help sailors feel connected. A hot meal after a long shift provides comfort, especially when far from home. For holidays, the dining halls are decorated, and special menus create a festive atmosphere, easing homesickness. Sailors often say a good meal feels like a moment of normalcy in their challenging lives. With so much food prepared, waste is a concern. In the past, food scraps were dumped into the sea. Now, many carriers use composting systems to reduce environmental impact. These systems turn waste into compost, showing the Navy's effort to be more sustainable. The culinary team's work goes beyond cooking. They train to handle emergencies and adjust operations during combat missions, ensuring meals are always available. Feeding 5,100 sailors every day takes planning, teamwork, and dedication. The chefs and their crew keep the carrier running by keeping the sailors strong. Their efforts prove that even at sea, a good meal can make all the difference.
The AR-15 rifle's history traces back to the 1950s, when it was originally designed by Eugene Stoner as the Armalite AR-10 for military use. This innovative design featured a lightweight, modular approach that emphasized ease of use and accuracy. In the early 1960s, the design was adapted into the AR-15, a semi-automatic variant intended for civilian use. The AR-15 gained prominence when the rights to the design were sold to Colt's Manufacturing Company, which rebranded it as a versatile and customizable rifle for the civilian market. Its reputation was further solidified during the 1960s and 1970s, when it was marketed as a reliable firearm for sports shooting and self-defense. Over the decades, the AR-15 evolved through various iterations incorporating advancements in materials and technology. Its widespread use and adaptability contributed to its status as a prominent firearm in American gun culture, leading to its role in ongoing debates over gun rights and regulation. The design and production of AR-15 rifles rely on sophisticated engineering and cutting-edge technologies. To determine the specifications for manufacturing, engineers perform module calculations using detailed parametric models and finite element analysis feed. High-performance materials, such as alloy steels and advanced polymer composites, are chosen for their mechanical properties and durability. Computer-aided design CAD is employed for creating precise digital blueprints, while computer-aided manufacturing CAM optimizes machining and fabrication processes. Additionally, additive manufacturing, commonly known as 3D printing, is used for rapid prototyping and producing complex geometries with high accuracy. These technologies collectively enhance the efficiency and quality of AR-15 production. Building on the advanced design and technology steps, the manufacturing process of the AR-15 rifle progresses through several crucial stages. Initially, high-grade materials such as aircraft-grade aluminum alloys and high-strength steel are meticulously selected to ensure optimal performance. Subsequently, CNC computer numerical control machining is employed to achieve precise tolerances and intricate geometries, aligning with the specifications established during the design phase. Following machining, aluminum components undergo anodizing, an electrolytic oxidation process that enhances surface hardness and corrosion resistance. In addition, the barrel is treated with a chrome lining through a chemical plating process, which improves its durability and resistance to wear. Moreover, steel parts receive nitride hardening or salt bath nitriding, which significantly boosts surface hardness, fatigue resistance, and corrosion protection. These interconnected manufacturing steps ensure that the AR-15 rifle is both reliable and durable under demanding conditions. Building on the advanced design and technology steps, the manufacturing process of the AR-15 rifle progresses through several crucial stages. Initially, high-grade materials such as aircraft-grade aluminum alloys and high-strength steel are meticulously selected to ensure optimal performance. Subsequently, CNC computer numerical control machining is employed to achieve precise tolerances and intricate geometries, aligning with the specifications established during the design phase. Following machining, aluminum components undergo anodizing, an electrolytic oxidation process that enhances surface hardness and corrosion resistance. In addition, the barrel is treated with a chrome lining through a chemical plating process, which improves its durability and resistance to wear. Moreover, steel parts receive nitride hardening or salt bath nitriding, which significantly boosts surface hardness, fatigue resistance, and corrosion protection. These interconnected manufacturing steps ensure that the AR-15 rifle is both reliable and durable under demanding conditions. The AR-15 rifle has emerged as a powerful symbol of American identity, embodying both the principles of personal freedom and the cultural significance of gun ownership. For many Americans, owning an AR-15 is seen as a manifestation of individual liberty and self-reliance, reflecting a long-standing tradition of firearm ownership as a cornerstone of freedom. This perception is deeply rooted in the nation's history and values, where the right to bear arms is often associated with personal autonomy and resistance against tyranny. However, this view is complex and contested, as the AR-15's association with high-profile incidents and debates on gun control highlights the ongoing discourse about the balance between freedom and public safety. The rifle thus represents not only a symbol of freedom but also a focal point in the broader conversation about responsible gun ownership and societal impact. The views we present here are based on personal perspectives, not excluding, condemning, or criticizing any behavior, attitude, or viewpoint of any individual or organization. We encourage smart viewers to filter necessary and useful information and be aware of protecting the health and safety of themselves and those around them. Finally, don't forget to subscribe to the Trending Farm channel and turn on the notification bell so you don't miss any videos exploring the livestock industry and modern food factories. Goodbye and see you in the next videos.
Peshawar, Pakistan is home to a unique industry where skilled workers craft guns by hand in the city's small industrial market. This 12-minute documentary takes you inside Farman & Sons, a family-owned factory, to show how pistols are made, the people behind the work, and the cultural role of guns in this region. The process is legal, licensed by the government, and supports hundreds of local jobs. You'll see the detailed steps of gun making, meet the workers, and learn why this craft matters in Peshawar. The small industrial market in Peshawar is a busy area filled with workshops producing pistols. Farman & Sons, one of many factories here, employs about 300 workers who earn 30,000 to 50,000 Pakistani rupees weekly, roughly $100, 0 cents to $180, 0 cents. This is more than many local jobs like truck driving, which pays about 20,000 rupees monthly. In Peshawar, especially among Pashtun communities, guns are a symbol of pride and security, not violence. Unlike some places, mass shootings are rare here, as gun ownership is tied to tradition and protection. You'll meet workers, including a 12-year-old apprentice learning the trade and a veteran engraver with 15 years of experience, showing the range of skills in this industry. Now let's explore how these guns are made. The process begins with workers specializing in different tasks to build a pistol, which takes 4 to 10 days. One worker focuses on the frame, another on the barrel, and others on the metal slide. The factory produces copies of well-known designs, like American Glock and Italian CZ pistols. Workers start by assembling polymer frames and metal slides. Then, skilled craftsmen hand-draw designs with pencils before engraving them onto the metal, a process that requires years of practice. This hands-on approach, without heavy machinery, highlights the artistry involved. Next, the pistols are painted in a dedicated area. Workers spray colors, like matte black or glossy finishes, onto the guns. After spraying, the parts are baked in ovens at 300 degrees Celsius to set the color. This ensures durability and gives the pistols their final look. Safety is critical during this process, and all work is done by trained professionals in controlled settings. A disclaimer for viewers. Firearms shown here are handled by experts. Do not attempt to replicate these processes at home. The workers' stories show the human side of this industry. Many start young, like the 12-year-old apprentice learning to assemble frames. Others, like the engraver, have spent decades perfecting their craft. These jobs pay better than many office roles, challenging the idea that only educated professionals earn well. A worker shares that he takes pride in his work, supporting his family with his wages. The industry's efficiency comes from each person mastering one stage of production, making the process faster and more precise. This specialization allows Farman & Sons to produce high-quality pistols that meet local demand. The final step is testing the pistols in a secure area with sandbags to catch bullets safely. Trained professionals fire the guns to ensure they work correctly. Another disclaimer, firearm testing is done in a licensed facility by experts. Only those with proper training and permits should handle firearms. The host observes the process, noting the loud noise and careful handling required, but does not fire the guns to emphasize. As the documentary closes, we reflect on the cultural and economic role of this industry. In Peshawar, guns are more than tools. They're part of Pashtun heritage, carried for pride and security. The factories provide jobs that sustain families and communities, showing the value of skilled trades. Unlike white-collar jobs, these roles offer good pay without requiring formal education. The host visits another smaller factory with 40 to 50 workers, seeing similar craftsmanship and learning about models like the Beretta, a blend of American and Italian designs. Standing outside the small industrial estate, the host summarizes the experience. Peshawar's arms industry is a blend of tradition, skill, and economic opportunity. The factories and shops line the streets, legally producing pistols for local use. Final disclaimer, this documentary is for education only and does not endorse firearm use. For safe firearm practices, consult local regulations. To learn more about global crafts, check out other documentaries on our channel. Thank you for watching.
Are you fascinated by the world of firearms? Each year, over 12 billion bullets roll off the production lines of cutting-edge processing factories, driving the evolution of the ammunition industry. But what makes the transformation from raw metal to high-pressure 35,000 psi resistant bullets so remarkable? And why is absolute precision non-negotiable? Join Trending Farm as we uncover the answers in this exclusive documentary. Ammunition production has evolved over 1,000 years, beginning with the invention of gunpowder in 9th century China. By the 14th century, firearms emerged, using stone and metal bullets. The 19th century introduced rifled barrels, pointed bullets, and centerfire ignition, improving accuracy and reliability. The 20th century saw advancements like armor-piercing and explosive bullets, revolutionizing combat. Innovators such as Peshawar and Hiram Maxim played key roles in this transformation. Today, leading ammunition processing factories across the U.S., Europe, and Asia utilize cutting-edge materials and precision engineering to produce high-performance bullets. Whether in the hands of soldiers, law enforcement, or sports shooters, these innovations redefine reliability and performance. From ancient gunpowder to AI-enhanced quality control, ammunition technology continues to shape global defense and security industries. Before bullets take shape in processing factories, the selection and preparation of raw materials play a crucial role in their performance and reliability. The modern bullet consists of 4 primary components. The case, typically made of 70% copper and 30% zinc brass, though steel and aluminum variants exist. The primer, a small explosive charge that ignites the propellant. The propellant, a specialized nitrocellulose-based gunpowder that generates pressures exceeding 35,000 psi. And the bullet core, usually lead, often encased in copper or featuring a hollow tip for controlled expansion. According to ballistics expert Dr. James Peterson, the quality of raw materials directly impacts a bullet's consistency, accuracy, and terminal performance. This precision is crucial for military forces, law enforcement agencies, and competitive shooters who rely on flawless ammunition for mission success. With sustainability in focus, over 90% of brass casings are now recycled, ensuring both efficiency and environmental responsibility. Did you know that a single bullet casing undergoes multiple precision engineering stages before reaching the final product? In processing factories, this begins with brass, an alloy of 70% copper and 30% zinc, carefully tested for quality. Using high-tonnage hydraulic and mechanical presses, raw materials are cut into blanks and shaped through multiple stamping phases. Advanced CNC lathes and milling machines refine details like grooves, ribs, and primer pockets. To withstand extreme pressure, casings are heat-treated at over 1,000 DGF and coated with nickel or phosphate for corrosion resistance. According to ballistics engineer Mark Reynolds, even a 0.01 mil defect can affect performance. That's why 100% of casings undergo rigorous quality control before packaging. Curious about what happens next? Stay tuned. From raw materials to precision power, how gunpowder is made. It all starts with three main ingredients: potassium nitrate, 75%, which provides oxygen, charcoal, 15% as fuel, and sulfur, 10%, to control the rate of burning. Next, the powder is pressed into granules of a specific size and dried to remove moisture. Ballistics chemist Dr. Robert Hayes notes that even small changes in composition can affect ballistic performance. While traditional black powder was used as a fuel for early firearms, modern smokeless powder made from nitrocellulose from nitroglycerin produces a cleaner burn and higher velocity. From ancient battlefields to today's high-tech processing factories, gunpowder continues to evolve, shaping the future of precision shooting. From precision to innovation, the future of bullet manufacturing Once shell casings, gunpowder, and bullets are ready, automated assembly lines ensure flawless construction. Each bullet undergoes AI-powered quality control, detecting microscopic defects in milliseconds. Only perfect rounds are packaged in moisture-proof containers and stored in temperature-controlled warehouses in processing factories for global distribution. But manufacturing is evolving. Lead-free materials and smart bullet technology are reshaping the industry. Beyond innovation, safety, regulation, and responsible use remain top priorities. Ammunition is evolving faster than ever, with AI precision, sustainable materials, and next-generation bullet technology shaping the future. Want to see how this transformation impacts military defense, law enforcement, and competitive shooting? Subscribe now and don't miss our exclusive coverage.